So yeah, today we're going to be talking about sustainability for workloads in Google Cloud. So what is sustainability, right? It improves your quality of life and your ecosystem, your environment, and you're really concerned about future generations. The keyword here is future generations, by the way, because I'm quite young, and I also want like older generation to care about what's going in the future, right? Um, So what is going to be the agenda? I will introduce how I really got into this topic in the first place. I'll tell you my personal story, where I come from, what I do. I'll introduce the shared responsibility model. This is a specific term that we use in cloud computing. Yeah, I'll quickly show some design principles that you can do on your project, right? Especially if you're an architect, please do this kind of stuff. And then I will demonstrate some best practices. I mean, not demonstrate, but more like talk about them. So if you're a DevOps engineer or cloud or platform, you should really keep this stuff in mind because they're not only for sustainability, but in general, they're really good practices to stick to. And yeah, at the end, if you'll have some questions, of course, you can ask me. So about me, I am currently a student at Venezia State University. I'm graduating in January, so I'm really excited for that. I also work as a systems engineer at EPAM. And when I was walking down the stairs, some boys looked at me and they're like, "Oh, she's probably a business analyst or something." But no, I'm a systems engineer. I contribute to a lot of open source projects, which I'm really proud of. I'm a big community player, and I also organize Rust community. And if you're into Rust, I'll also mention this in my presentation, but come to me, I have some stickers. And yeah, I do some other cool stuff except talks, and I talk about different things. You can check my LinkedIn or give me a follow on GitHub to see what projects I'm contributing to. So I guess we can just get started into my story, right? So some time ago, I participated in a hackathon, and actually I won this hackathon, and I was grouped with a team of solution architects, and these guys are like really experienced. They're quite old. They had, I don't know, work experience, probably same ages that I have, and I'm only 22. And yeah, the hackathon was 2 week, and during these 2 weeks, I gained a lot of insights about what's going on, what's the actual reality, and I was somewhat disappointed because 2 years ago, or actually year and couple months ago, when I started my journey as a systems engineer, I went through a big process of training. And I read a lot of books, and this topic was never mentioned. And even on the projects, no one really talks about this, right? And even when I talked to these solution architects, they also didn't really have a big idea of like what's going on. And I was like, okay, guys, it's a bit strange. So I was like, what's going on? Why is there a lack of sustainability best practices everywhere? Like there has to be a specific reason, right? And yeah, maybe you have also noticed that this topic is not something that is talked about on your project and people don't really implement anything about it, right? So what happened? I'm really positive about sustainability in general, and I try to be more, how do I say, like think about environment. And I also understand that since I work in IT, I have a lot of e-waste that I produce. But I thought, okay, so projects don't care about this. And I realized that actually projects are always struggling. It's not something new. And you have different issue like, let's say, lack of skill set, and you have to train your engineers to gain some skills. If you're lacking them, you have product management confusions and just management issues in general. You will have a lot of unreal expectations, especially if the project is really big and you have like a really strict client. You have to I don't know, make some expectations, but at the end, you never really end up sticking to them. And I realized that only in really, really well run and architected projects, people have time to talk about sustainability, which is really sad because really good projects are something rare to come by, right? So I'm really curious, and I really like, I don't know, if something's missing in my life, I go and search for it. And I decided to contact all these like crazy companies that I knew they were doing something with sustainability because they had posts maybe on LinkedIn, or they have like blog articles about this topic. And I asked like, guys, can you tell me, can you share with me like why you're deciding to talk about this and put this topic forward in general? And they basically told me, which is really sad, that first of all, when you have a company and you're looking for investors, they're more likely to invest in your company if you're talking about this topic. And I was like, oh my God, okay, this is really bad. So you're doing this for marketing and you're not doing this because you actually care. And yeah, it was getting really bad. So they said, yeah, to appeal to customers, to get good funding, investors are really into it, and also the users are also usually into it, like people like me that's into sustainability. And I was really disappointed, you know. And I was looking for some more real life examples, and I contacted the senior solution architect at AWS that was really kind enough to reply a really long message, and we still keep in touch regarding this topic. And he basically told me that depending on where you live, sustainability is a bigger or lesser focus. And he told me that he had clients from Netherlands and UK, and they start implementing these sustainability best practices on their projects. But he said this was due to government regulations that came in their countries. And I was like, you know, I come from Georgia, relatively developing country. It's not like UK or Netherlands at all. And then we have like tons of other things we have to worry about before even getting to sustainability. So the government will never bring these regulations, as there's other regulations that we have to think about and prioritize. And I was like, okay, maybe political regulations will change this one day. But right now I'm quite disappointed, and I think I'm really pessimistic with my outlook on this topic, and it's greenwashing, right? And I was really unhappy for quite some time, until I realized that I was complaining too much, and self-criticism is also necessary from time to time. And I realized that although company attitude is standing in the way, and you can always like point fingers at the management and tell them what a crappy job they're doing, you should also, as a developer or as an engineer, understand what you're doing. And if there's something you don't like, are you trying to change it? Is there any way you're trying to work on it? So I decided, okay, I won't point fingers, and I'll work on this topic myself, and I'll educate my colleagues myself. And I will write emails to the management every day and force them to let us work on these best practices and actually implement them. So this brings me to the shared responsibility model, right? And actually, the environmental sustainability in cloud is a shared responsibility between the customer and the cloud provider itself. So we have two types of sustainability. One is of the cloud, and the other one is in the cloud, right? And basically, the cloud is responsible for optimizing the sustainability of the cloud. Like they have to think where they're outsourcing their energy from. Is it like clean energy? What materials they're using to build their data center? Let's say resource utilization, and being transparent with the client of everything that's going like behind the scenes, let's say it that way. And on the other side, we have something called sustainability in the cloud. We as people that utilize the cloud, what do we do to stay sustainable, right? Because cloud is sustainable, and it's a fact that it's more sustainable than building an on-prem infrastructure. But what best practices do you have? Do you even optimize your code to be sustainable? Let's say, are you creating infrastructure manually, or do you use infrastructure as a code approach? Yeah, are you even thinking about reducing energy in general? And yeah, it's a really continuous and big effort, because the best practices are changing from time to time, not only in regards to this topic, but in general, right? And yeah, I decided to research this topic. And first, I'll talk a little bit more about boring stuff, like how you should design your project so you don't miss this stuff to start from. And then I'll show you some more systems engineering or cloud or platform engineering things that you can do. So what design principles should you have inside your cloud? First, I would advise that you should understand your impact. And people often think that this impact is only what you're producing while you're creating application for your clients, right? But actually, the impact is also from your customers that are using your application, because they also produce e-waste when they use your software that you're providing them, right? And you have to think about really a lot of stuff like decommissioning your application. That is also a lot of waste. Also, you have to sometimes compare different clouds, what different things they offer. Maybe the solution is not as good as the other one that you have. And yeah, so on. Next, which companies don't like, is to establish goals. And we all know, if you have worked on a really large scale project like I'm working on, that people don't like long-term sustainability goals. They prefer something shorter where they can see what's the word? They can see what it brings, right? Which is really sad, because sustainability is not something you can change like this. You have to work on it for a long time to see a big improvement. So it's difficult for companies to stick to it, but you have to force them. And next one would be to maximize utilization. And basically, it's just a way to find right-sized workloads and implement, let's say, efficient designs on your project, right? Then it brings me to use managed services. Basically, if it applies to your project, please try to use cloud for everything. It's much easier to understand what you're lacking or what your emissions are for CO2 as an example, because you have calculator inside cloud. All cloud providers provide this, by the way. You can also see how sustainable your current region is, the one that you're picking. You can also have more detailed logs, because if you have on-prem and cloud mixed together, it can get a little bit complex from time to time. So yeah, use managed services. And next one is anticipate and adopt new solutions, which also means please read the documentation, because cloud comes out with new solutions quite a lot, especially the machine types. There's a lot of new machine types that come out from time to time. So please check that out. And yeah, I don't want to bore you with this stuff anymore. Here I'm providing you a really cool article written by Tom Kennis, and he's a sustainability cloud and DevOps consultant, and he has been devoting really a lot of work and time into this topic. I also talked to him before I put everything together in the presentation, and he's really nice. And he wrote this article about the current status of carbon footprint in IT, and it also explores like mathematical calculations of how he calculates all this stuff, and it's really cool. You should for sure check it out. So yeah, this is a little bit of my backstory of some design principles I advise for projects to try and implement if it applies for you. And now let's get into my favorite part, which is criticizing a lot of DevOps or systems engineer, including myself, and how terrible we sometimes work, right? So first thing I want to talk about is data in general. A lot of common mistakes that you will see on projects, doesn't really matter the size, is that they duplicate data that can be easily obtained or recreated. They also back up all the data without considering its criticality. Then they delete data irregularly. So on a really good project, you will have a specific day in month or sometimes even week, if it's like a really big project where you process a lot of data. And on this specific day, you will start deleting the data that you no longer need. The next one, which is a big mistake from DevOps side, is you store data redundantly, irrespective of your storage service durability. So let's say in Google Cloud, we have object store. In AWS, we have S3 buckets, and they're different. There's different types. So you have to consider that. And this one is the one that drives me crazy all the time, is that people turn on object versioning without any business justification. And yeah, as I mentioned, if this applies to your project and you work with a lot of data, and you probably do, let's view some implementation guide that I think you should be doing to save energy and money. But before, I want to say that you have to think about risks that are associated if you try to change the stuff on your project, right? And in my opinion, if you're working with data, the risk will be from medium to high, depends on what kind of data you're processing. But some implementation things that I think everyone should do. Please, first of all, write documentation. Who here writes documentation? Please raise your hand. Okay, this is pretty good. Okay, in Budapest, there was only 2 hands, which was really terrible. So write documentation, because if you quit one day, right, and someone has to replace what you were doing, they will have no idea about what was going on. And I remember when I was doing an internship in university, it was big pharma company, right? And we had object store or S3 bucket. And I remember I found this bucket, and it had like 780 gigabytes of data inside. And I also checked logs when it was last time accessed by a developer, and it was like 10 years ago. Okay, not 10, but it was like 5 years ago. Okay. And I went to my team lead because first of all, it's a lot of data and you're wasting money and energy, of course. But I went to the team lead and I asked, do we really need this data? And I remember we were in the call and his face in the camera changed and he's like, we don't know. And I said, what do you mean we don't know? And he's like, we don't have documentation. This existed before I came here. So I cannot take responsibility to delete or change anything that's inside this data. So yeah, this is like an example of why data is really important, why writing documentation is really important, right? Next one would be to implement a backup strategy. Don't back everything up, right? There will be some data that can be recreated really easily. You don't have to back it up at all. You don't even have to save it, because you can probably or most likely recreate it really easily. And also, if you work with data, you will know that on the internet, you can find free data sets. And of course, you can use that in your project if it applies and if your management is fine with that. And yeah, there's different types of strategies of backing your data up. I'm not going to get into detail regarding that. If you're interested, you can come to me later and I can talk to you about it. Next one would be using policies. Has anyone here tried to delete objects or some data from object store or S3 bucket manually? You guys have tried it? Oh my! So you know how pain in the ass it is to like
try to post manually on the Terraform, and I had to try and error all the policies. Give me access to permission for deletion.
Yeah. First, that's the issue, and this other issue is that if you have 780 gigabytes of data, you have to delete file by file. It takes, I don't know. I don't even want to like imagine how long it takes. So we have something called policies, and the smallest amount of time is like 24 hours, and you define in your policy what you want to happen with this specific bucket or object store or whatever. And if you want to remove it after 24 hours, this deletion policy will remove and wipe everything that was inside, and it's gone forever. So yeah, not only for removing, but it can be for duplication, for backing up. You can use policies. It's really handy. So never do it manually, right? Next one, as I said, you have different types of object stores or S3 buckets in AWS. And you have to understand what kind of data you're dealing with. If you're accessing data really frequently, you will use one type. If you're using data once in a while, you will have like a specific archival or deep archive, it's called on AWS. You will be using that one. And of course, they all have, what is really good is that they all have different prices. And of course, if you're accessing data once in a while, you can use a specific bucket that is more energy efficient than the other ones. So it's really sustainable. And people usually ignore this like fully. Next one is probably keeping all your system logs together in one place. And you should like remove repeated entries to make logs less confusing, right? And no one likes reading logs in Google Cloud and both AWS. I didn't work with Azure that much. Logs are so bad. I don't know how to even like tell you, but I usually exported it to JSON and open it in a file to understand what's going on, because on cloud it's bad. So yeah, you can also adjust the level of information that you want inside the logs, and it just makes it easier to find problems and fix them. And as you know, if there's and if you're debugging something and you're leaving, let's say, a machine on for a long time and you don't understand where's the issue, you're wasting energy, right? So try to be more thoughtful about it, and you can do some specific alterations with your logs. Next one is cache, and this is also something that is really ignored, because you can speed up your system by storing frequently accessed information inside your cache. Of course, you will have to be a little bit, smart about how you store it and how you will be accessing the cache, because it can get a bit complex if you put too much data into it. But yeah, it's also one way. And yeah, you have to think about how you're saving the information inside your cache as well. And of course, please clean old stuff. Like, maybe you won't have documentation, but you see that some data is from 10 years ago. You will most probably never use it, and it's just there for, I don't know, God knows for what reason. You can probably take the responsibility and delete it, or try to restrict the access. And if no one comes for 90 days, you can probably guess that, okay, it's not used, and I can most likely remove it, right? So yeah, this is my take on data and some stuff that people usually ignore. The next one is a bit more fun. It's about machine types, or in AWS, we call them EC2 instances, or machine families in Google Cloud. Some common mistakes. You're only using one family of instances. Terrible. I don't know why people are doing this. You're only using x86 instances. Also really bad, because you have ARM, which there's a lot of research, and even the reason why they came up with ARM processors is that it's much more efficient and it uses less energy. Then we have something called scaling configuration. So if suddenly there's a lot of traffic on your machine, you can scale it. We have different types of scaling, but you can put the specific type of instance that you want inside your scaling configuration. And people always specify only one type of instance, which is a really bad approach, because you can specify different ones depending on your needs, depending on what kind of traffic you are thinking will come for your application, right? Next one, oh my God, this is terrible. This is also something I had on my internship, is that people will use instances in a manner that they were not designed in. So let's say you have a compute optimized instance for a memory intensive workload. Like, it doesn't add up at all. You should not do that. And yeah, as I mentioned, redocumentation, because cloud comes up with new instance types a lot. And maybe it's something that you will more or likely use more than the other instance type. Let's say you have, I don't know, like a machine learning application and you need a specific type of a family of instances, just look into that, right? And yeah, actually, the risk won't be that big because cloud is really flexible and you can always test the machine before you actually put it to your prod use. And it's really easy to test it out, right? Just try to run your workload inside for just 1 hour. It should not be expensive. And yeah, if possible, you should also modify your workload to work with, let's say, different amount of virtual CPUs and different amounts of memory to maximize your choice of instance type. So yeah, just also my take on machine families. Probably there's other things that can be more advantageous, but the specific x86 is something that kills me because I don't know, it's something like cave time approach to just use this, even though it might not be needed at all. So after instance types, we can move on to geographic locations, right? So first, let's say common mistakes you will see on the projects. You select the workloads region based on your own location. It's such a selfish approach. And we'll get into this why if you don't understand what's wrong with this approach. Next one, you consolidate all workload resources into one specific geographic location, which is also really bad because you can split your workloads into different locations. And I'll explain that also why. All traffic flows to your existing data center, also quite bad. So yeah, what you should improve, and I think risk will be somewhat like medium, in my opinion. Choose correct region, right? Google Cloud is really cool about this because you can see a percentage of how sustainable at that moment this specific region is. Really crazy. I didn't see this for AWS or Azure at all. Sadly, you don't know where the energy is coming from, but you can see how clean at the moment that region is, right? Let's say for data-heavy applications, let's say you have big data or you have machine learning, application code should run as close to a data center as possible, right? Because if you have, let's say, this type of machine learning application, you have to transfer data from one spot to another, and it creates latency. But also, if it has to transfer from one specific part to another, and if the distance is really long, you can imagine how much energy you're spending in that, right? So you should, of course, try to keep the code and data as close to proximity to the data center as possible. And this reduces a lot of energy consumption and, of course, lowers the data transmission, and it's going to be much faster. And yeah, try to think about your clients, because if you're developing a software product for people that are placed in Japan, but you work from, I don't know, let's say from Georgia, from where I come from, they have to connect to Georgia, right? To my region. And it's also quite big connection, distance, exactly. Distance that they have to do. So yeah, try to put your region or choose your region closer to your workload users. And yeah, you will have to consider one constraint, and this constraint is cost. As you know, different regions have different costs associated with them, and this cost also changes from time to time. So it's really important to see how much it costs at that moment, right? Because if you suddenly migrate your workload to a really expensive region, your team lead or your manager will come and they're not going to be happy at all. It happened to me. So yeah. Okay, next one. Do you have any mobile developers right now inside this room?
I used to be.
Really? Okay. Really fun. Really cool. So have you guys heard about device farms? No. Okay. So first of all, there's 3.8 billion smartphones in the world, and I'm not even giving you numbers of how many of them are thrown away each year because new phones come out. And as we know, the phones are not fully recyclable. So it's really, really crappy. It's not sustainable at all. And let's let's get in the mind of a mobile developer. What you have to consider when you're developing an application. Different devices, you have different brands. You have to think about specific circumstances, like how much battery your phone or the specific type of phone has. As an example, I'm using iPhone 12 mini and it dies really fast. So yeah, when you're writing application, you have to think about this kind of stuff as well, right? Another one would be screen resolution. You have different screen resolution on different phones. If you live in Georgia, your network connection will be crappy compared to Italy. So if you're developing an application, you have to think, okay, you have to. Really? Oh, okay. What about electricity outages? I'm pretty sure that happened. Yeah. See. Okay. That's an issue. Yeah. So poor network connection. Different versions, because as you know, even though I have iOS, I have a specific version, and someone that has older phone will have different version. And yeah, it gets really complicated because. In 2020, they did a study where 60% of application users think less of a brand if it provides a poor mobile experience, and 70% of users will abandon an application if it takes too long to load. So imagine you're like a startup and you have a really cool idea and you start implementing it, but it's taking too long for it to load for some poor people that live in Georgia, let's say, right? They're gonna abandon it. And if you're competing on a big market, you're gonna, I don't know, it's gonna go really bad for you. And there's gonna be some startups that are gonna get all the way up and you're gonna go down and sink, right? So what is device farm? Basically, if you want to test your application on your phone, what companies do is that they buy devices, and you usually have a device that they give you where you can test the application. And this is a really bad approach. I already explained what's going on with devices, but also it costs money. And there's another issue that, let's say if you're an international company, you will need to either send out the phones to your employees, or they have to come physically inside the office to test the application on the phone. And the cloud, especially Google and AWS, they both have the solutions. I didn't look into Azure. They have something called device farms, where you basically rent phone virtually on cloud, and you can test your application there. And it's much cheaper, much more sustainable. Cheaper because those that have worked with cloud, you know that we have something called pay-as-you-go model, and you only pay for the resources you're using, and you also pay for time. So like 1 hour of renting this device farm. And yeah, also you don't have to pay for your employees to come. And as you know, transport is also associated with carbon emissions, especially like planes. When you're buying a ticket, you can also see how much carbon emissions your airplane ticket will have. And yeah, it's much more sustainable approach. And not only do you save energy, but saving energy correlates with saving money. That companies a lot of time totally miss this point, right? So because we have some mobile devs and systems engineers don't really write that much code, you guys do. I will talk about optimizing your code and not writing shitty code or bad code, as we call it. Common mistakes that you will see from developer side. I also come from developer background, just in case. You ignore optimizing your code for resource usage. It's something that is totally ignored. You usually respond to performance issues by increasing the resources. Oh my God, this is so bad. Okay, please with raise of hands and don't disappoint me. Who actually does code reviews here? Good code reviews. Okay. Because I've seen sometimes this tendency with developers, especially, they just open the code, they're like, it passes the pipeline. Okay, I can just push approve. Don't do this, guys. Because there could be some optimization inside the code that you can most likely do. And yeah, please track this performance changes. Benefits of implementing a better approach to how you're coding, and if you're, let's say, doing code reviews and approving pull requests, is that using efficient code or writing efficient code, of course, minimizes resource usage and it improves your performance, right? So yeah, please actually review the code. Use the most efficient, what is it called? Programming languages, if I can say it this way, or libraries that are out there. And if it's possible, sometimes you can even remove like unnecessary code. And I call unnecessary code such things as formatting, or you can have sorting as an example. And sometimes you can even change specific algorithms for something more simpler, right? And this brings me to also being more thoughtful about what programming language you're using. And as I said, if someone has heard about Rust here, I'm a big Rust evangelist. And in, I think this was in 2020, 21 maybe, they did research about 27 different programming languages, and they compared energy, time, and peak memory use of these programming languages. And as you can see on the benchmark, you have C and Rust all the way at the top. Then you have C++, Ada. I don't know who codes on Ada, but I guess we have Java, and all the way down we have Python, right? And this brings me to a really sensitive topic, because I had this case where I started writing some stuff on Rust in our project. And it went all really well, and I demonstrated that it saved a lot of money. It was a Lambda function in AWS. And a couple days ago, if you watch reinvent, they also did a really cool demo how like a 1 million if you run a function 1 million times on Rust, it will be $2.98, but on Python it's close to $10. And of course, Rust is more energy efficient. Of course, if you're interested in that, I can talk about that a little bit later. But my point here is the sensitive topic that when I wrote all this code on Rust, at certain points they were really happy, but they said that I will have to delete it, and I was devastated because I put a lot of work into this, and we actually saw that it worked, and it was really good approach into what I was trying to solve at that moment. But they said that they don't have Rust developers, right? And even if they will get Rust developers at certain point in time, they will be really expensive. So projects are really trying to save a lot of money, and you will see they will always try to find a Python developer, because as they explained to me, they're the cheapest to employ, which is really bad. It's super unsustainable. As you can see, the energy consumption is like all the way down. And someone will start arguing with me, if you're a Python dev, that you have multi-threading in Python now, and it's much more energy efficient, and so on and so on. But no, I can also show some other stuff. So yeah, and there is a specific company. It's called Tenable. It's a cybersecurity solutions provider, quite a big company. And they had basically like a sidecar agent on their project that filtered out unnecessary metrics, right? And it was fully written in JavaScript. And yeah, it was working in production for a couple of months. And one day the performance started to degrade due to scaling. And they decided to rewrite just a small part of it, just a small module, which was the filter, into language Rust, right? And they saw 50% of improvement in latency at both the median and P95. And they also saw 75% reduction in CPU usage and 95% reduction in memory usage, right? So this is also a really sensitive topic, because if you have a project where they were using one programming language for 30 years, it will be really difficult to introduce something new. But of course, there's always cases where you can rewrite something smaller into a different language, not necessarily Rust. I'm just a Rust fan, you know. But you have similar stories with other companies. Discord, as an example, is a great example, how they also rewrote some stuff into Rust, and it was not only faster and more secure, but also saved a lot of energy and money at the end, right? And yeah, this also brings me to increasing utilization of build environments. Some common mistakes that you will see. You manually provision or terminate your build environments. Or you keep your build environments running independent of test, build, or release activities. This is like really bad. It's out of my mind. And there's also cases, if applicable to your project, that you have a team that works only during the weekdays, sorry, but on the weekends, the pipelines are still running and the build environment is also still running. I don't know why. It's really bad because you're wasting so much energy during these 2 days. And if you just turn it off, you will also save money. And what big projects always like to see is like numbers of how much they saved in this amount of quarter of the year, right? And another one is that you over provision resources for your build environments. Sometimes you don't need as much resources as you think for things that you're doing. It's always much better to go to a DevOps or a cloud engineer and ask them, if you're a developer, that are these things like really necessary? Will I need to use all of them? I think they will respond to your questions much more easily, right? So yeah, what you can improve. We have something called serverless. I think some of you might have heard serverless. If you have worked with, let's say, Google Functions or Lambda functions on AWS, it's also serverless. They leave for like 15 minutes and then they time out and you have to restart it. But if you have something that's applicable for this instance where you don't have to run everything for a long time and it's just something really small, you can use serverless instead of a whole big machine that's running behind it, right? Next one will be infrastructure as a code. So we use something called Terraform. If you're a DevOps, you will probably have heard about it. Even if you're not a DevOps, maybe you also know about it. And I had so many cases like this where I scan our infrastructure from time to time. And I see that there's some stuff that was manually created and it was never removed because no documentation and people forgot about it. And when we keep everything in our code and we're deploying it, things that were created manually, they don't get erased. They just stay there like that and hang on for a couple of years sometimes until someone like me scans and finds it and deletes it, right? So yeah, don't create things manually. If you're a DevOps, you can use Terraform. If you're a dev, you can create a ticket and DevOps will be so much more happy to read the ticket and implement it. Yeah, and yeah, shut down workloads on weekends if applicable to your project. Force your team lead to turn it off on the weekend. Like it's fine. No issue with that. And yeah, the last thing I want to talk about is to educate your community. Like as me, when I saw that there was some gap, because I did like a research of 100 people, 100 DevOps, and I asked them if they knew about this specific topic, and they responded no, and they also said they never had it on their project, which is a little bit concerning. If you see that there's something that's lacking, yeah, try to learn it yourself and then share your knowledge with others. It's a great feeling to try and transport your knowledge to someone else, right? And here I'm sharing a link from Green Software Foundation. These guys are really cool. They deal with all things sustainability. This one is specifically for cloud, but if you check their blog and their articles, you will find talks about code optimization, about Rust as well, if you're into Rust. And yeah, people here are from like all the big different companies, from Microsoft, from Google, from AWS, and they come together and create this really cool community, right? So yeah, if you have any questions, I hope you learned something new today. I maybe taught you and gave you a look of reality of how bad things are currently. If you have any questions, I'll be so happy to respond to them. Any questions?
I have one.
Uh-huh.
Do you think that the edge network is sustainable?
That's a good question. Yeah, I think it's much more sustainable. But it also depends on what kind of project you're trying to use an edge network on, right? Because you have different types of projects that might not fit this specific use case. I should think about like which project won't fit it exactly, but I think overall, yeah, it's much more sustainable.
Because like, as far as I understood, one of the ideas behind edge computing is that you should also replicate all your data for every
For every part.
So
That's a good question.
yeah,
Because you have the integration with CDN, so you don't need to kind of manually allocate the data in the region that's closest to the user.
Yeah, closest to the user.
That's the location problem.
on this side, everything is much cheaper, but you have to replicate a lot. So where is the trade-off?
I have to think about this to answer you a little bit, right? I have to think about it. I never thought about it in that way. Any other questions?
For most companies, so like let's exclude Google and Facebook from the equation. For most companies, they think that most of their inefficiency and the lack of sustainability comes from the software they provide or from the practices they impose to their employees.
Practices.
Come to the office, travel, I don't know, 30 minutes or 60 minutes, depending, especially in the US.
I think it's a little bit of both, but I think mostly about the best practices that they try to instill in their employees. Because of course, if they show this type of presentation, not only to the developers, but also to the management, of course, everyone can learn something and be more, what's the word? Like think about this, that this issue exists, right? So yeah. But of course, there's different projects and smaller projects. Actually, really surprising, the small projects are the ones that usually even think about this kind of stuff. Maybe for marketing purposes, but still they think about it.
It's for money.
Huh?
Also for money because it's strictly related to money.
Yes, it's directly.
For example, I'm working in a startup that we founded 3 years ago. Now we have grown a lot in Europe. And for example, the cost of we are using GCP. And we reached a point that we spent per month like 7K on useless stuff like some family machines that were way more powerful than the actual resources we needed. Or database.
Yeah.
Shipping management of database. Then we completely refactored almost everything. Now we are spending like 1K.
Really? Wow. So yeah, that's a big change, right?
Yeah, also we have several solutions for example, we are using microservices architecture and some microservices we are running them in Kubernetes due to the business. But others like payments that are not so common, we are using code functions.
Yeah, exactly.
The code is completely different.
Yeah.
And so also the database consumption is completely different.
Yeah.
And it costs a lot.
Yeah. So see, guys, a really good example of how much money you can save and also be more sustainable about the resources and energy that you're using, right?
And that was so easy to to ask our managers to can we implement this practice? Why? Yeah, because if you say you will spend like 5K less. Okay, I show you.
Yeah, see? Yeah, money always motivates everyone, which is sad, but yeah, sometimes money is here and morals are here, but yeah, things like that happen. Yeah. True. So any other questions? If not, you guys can enjoy the lunch break. Yeah, the lunch break. And I have some Rust stickers for those that are into Rust. Please come to me, I'll give them to you. I have a whole collection.